Hello geometry students, it's Mrs. Davitt here, and today we are going to look at one of the Chapter 10 circle topics, which involves using the diameter of a circle to solve other problems. So let's take a look. First of all, it's important that we recognize that if we have a diameter of a circle, we know that we are cutting that circle exactly in half, which means that either of these arcs is 180 degrees. So if we have an inscribed angle that intercepts that arc, based on the relationship between arc measure and inscribed angles, we know that this angle here will be half of that arc of 180, or in other words, it will be a right angle. So that's great news for us because now, if we have an inscribed angle and a diameter, we are always dealing with a right triangle, which means anytime we have a triangle formed by an inscribed angle and a diameter, and therefore a right triangle, we can use all of our right triangle tools. So this is the idea that's going to move us through several of our examples. So keep in mind that there are lots of right triangle tools at our disposal. We have Pythagorean theorem, we have right triangle trigonometry like sine, cosine, and tangent, we have inverse trigonometry, and we have special right triangles as well. So lots of good things going on here. So let's take a look. Looking at the first of these examples, we are given the radius as well as that one inscribed angle. So let's take a look at what we can do with that. First, we should probably just label our radius, which tells us that the entire diameter is 24, and that happens to be the hypotenuse of this triangle. Now, because this is a diameter, we know that this angle would be 90 degrees, even if it had not been marked that way. So we are now dealing with a right triangle in which we know one angle and one side. So if we want to find the area of the triangle, we would need the base and the height. So we could typically just use sine, cosine, and tangent to use the side we know and the angle we know. But take a look. That's a 30-degree angle, so you should be thinking about your 30, 60, 90 triangle relationships. So I'm going to label those sides up with the relationships that exist in a 30, 60, 90 triangle. Opposite the 30 degrees, I typically see a side of length x. Proportionally opposite the 60, I see x times the square root of 3, and opposite the 90 degrees, I see 2x. So these numbers are pretty nice. If 2x is 24, then x must be 12, and x root 3 would be 12 root 3. So I can go ahead and label the legs of my triangle accordingly. Now, this problem is asking me to find the area of the triangle, so once I have those legs, I'm just going to use my area formula, half base height, and plug in the legs of 12 and 12 root 3. And when I simplify that, half times 12 root 3 equals 72 square root of 3 square units. So in that problem, we actually used our special right triangles of 30, 60, 90 triangle relationships to complete the problem. In example 2, it's a little bit different. We are given one side in the triangle, the 60 degrees. Again, because this is a diameter, we would know this is a 90-degree angle, so we have a right triangle. And here you're actually given an arc of 80 degrees. Now, if that arc is 80 degrees, the inscribed angle that hits the arc, aka this angle right here, should be half of that, or 40 degrees. So now we have an angle and a side length, but it's not one of our special right triangles. So I'm thinking I'm going to use regular right triangle trig, like sine, cosine, or tangent, to find what I need. Now, we're being asked to find the circumference of the circle. So that means we need the diameter. So we want this side here, which happens to be the hypotenuse of the triangle that we're given. We have, in this case, the adjacent side in relation to the 40-degree angle and the hypotenuse. So I would relate those two sides using the trigonometric ratio of cosine. So cosine of 40 degrees equals the adjacent side, 6 over the hypotenuse. In this case, I've labeled it h, and that ratio is down here. Okay, so then when I go to solve here, I'll multiply and get h times the cosine of 40 degrees equals 6. I'll divide both sides by the cosine of 40 to get h by itself, and then I will simply type 6 divided by the cosine of 40 into my calculator and get a hypotenuse of approximately 7.83 degrees. Now, I'm ready at this point to find circumference because that hypotenuse again is our diameter. So keep in mind that circumference has two formulas. Circumference can be 2 pi times the radius or pi times the diameter. Since we have the diameter, I'd rather use this version of the formula. So now keep in mind also that we rounded the 7.83. So when I go to find circumference and I plug in that 7.83 times for the diameter, this is not exact form because that 7.83 is already rounded. So in a case like this where I already have a rounded value with pi, there's really no point in carrying pi in our final answer. That's because we typically carry pi in order to leave our answers in exact form. But since I've already rounded, I would prefer to just simplify 7.83 times pi in my calculator and get one final rounded answer. Keep in mind though, you should probably use that second answer feature and pull the exact answer as much as you can instead of this rounded 7.83. So when I do that, I get 24.61 centimeters. So that's the circumference. Last but not least, example number 3. Now, assuming again that this is a diameter, because we're dealing specifically with how we use the diameter in these problems, we would know that this angle C is 90 degrees. So we have a right triangle. Now in our first example, we used our special right triangles. In our second, we used our trig tools. In this triangle, it's a right triangle and we know two sides, so we can use Pythagorean theorem to find the third side. Now some of you may be looking at this triangle and realizing that you don't need Pythagorean theorem because you recognize that this is also one of those nice Pythagorean triples. But if you don't recognize that, that's okay. Quickly do Pythagorean theorem. Get c squared equals 100 or c equals 10. Now that's just a scaled up 3, 4, 5 right triangle. So if you recognize that 6 was 3 times 2 and 8 was 4 times 2, then you might have recognized that the diameter would be 5 times 2, 10. So that tells us that our diameter is 10 and therefore our radius is 5. So from here, finding area should be no problem. Area equals pi r squared. We'll plug in our radius of 5 and we get 25 pi square inches as our area. So that was us using Pythagorean theorem in this kind of problem, or our Pythagorean triples. Now if I wanted to find the measure of angle ABC is this one right here, and I can use those two legs, 6 and 8 that were given, or the 10, to solve for that angle. So thinking of my trig ratios, I could use tangent and set up this relationship. Tangent of that angle x equals 8 over 6, opposite over adjacent. To solve for x for that angle, I would use inverse tangent. That would simplify the left-hand side and just give us x equals tangent inverse of 8 over 6. And that x is angle ABC, so the measure of angle ABC would be approximately 53.13 degrees. So there's a whole lot of ways, as you can see, that we can use the diameter of a circle and apply that to work within our right triangle tools. So thanks for joining me.